Welcome to Spring LIB.
All right, so we haven't been shown the reactants, but they did tell us that it's phenyl bound to carbon, doubly bound to oxygen, and on the other side it's an oxygen and then an ethyl chain. So this would be like a phenyl ethyl ester. And on the other side we have looks like ethyl, basically another ester with an ethyl chain on one side, and on the other is a ethyl chain, right? So this is like a ethyl, I guess it would be a propyl ethyl ester. And what I'm going to do is color code this. So basically, note that only one of these esters has an enolizable proton, right? So this is going to be our sort of nucleophilic ester, and the other is going to be our electrophilic. And the nucleophilic is going to attack the electrophilic, and what's going to happen is it's going to lose its ester, right? Or I guess it'll lose. I guess we would say it's going to lose ethoxide, right? It'll lose an oxygen with a CH2, CH3, right? But it's going to gain a bond between this carbon, the carbon on our nucleophilic ester with the enolizable proton. We're going to gain a bond between that and our carbonyl carbon on the other side. Right? So if I wanted to color code this for a more sort of easy to see thing here, I'm going to draw this in blue, the carbon chain on our nucleophilic ester is blue, and we'll draw the carbon chain on our electrophilic ester as red. Okay, and then I'm going to draw the ethyl ester that we will lose in green. And now I'll redraw our original nucleophilic ester. Okay, like so. Nothing will change here. It's still going to be an ethyl ester, right? And none of this 3-carbon chain will be lost. But we will get a new bond from the carbon that had the enolizable proton and basically our red chain here. Right, so it'll be a bond between here and here. Right, so we'll still have a phenyl group attached, and we'll still have a double bond to oxygen, but we will have lost that ethyl ester group. Right, so this is the Claisen condensation, and our product is the so-called beta keto ester. Yeah, so that's how you can get to the product. And something like that, I would just kind of redraw the nucleophilic ester as is, chop off the ethyl ester from the electrophilic ester, and then create a new bond between the beta carbon of the nucleophilic ester and the carbonyl carbon of the electrophilic ester.